In today's lecture, we will study about the eigenvalue, values, eigen vectors. The concept is very simple. Simple is why? Because I am teaching and you are here. Yeah. So, but very useful, very useful. It is, you can say, comprehend all the linear algebra till today what we studied. Mathematical expression for this can be written like this, where A is any kind of a matrix. This V represents eigenvector and this lambda represents eigenvalue. This mathematical expression is telling us the two sides expression. One is the left hand side, another one is the right hand side. If we notice, on both sides vector V is common.
Yes.
Or in other words, you can say this matrix A somehow equivalent to eigenvalue. However, the important point is this: how we can know the eigenvalue. Remember, A is a matrix, but eigenvalue is one single integer quantity, or you can say scalar quantity. Then, if we familiar with some matrix A, for example, minus 6, 3, 4, 5, some kind of matrix A, and there is eigenvector V is equivalent to 1, 4. If we are considering the right hand side expression, we can multiply this matrix A with V. If we multiply first row minus 6 and 3 4s are 12, and what is 6? 4 1s are 4, 4 5s are 20, it becomes 24, so we will have 6, 24. This right hand side expression basically 6, 24 equivalent to what? This one, left hand side expression. This one is the left hand. Okay, sorry. This our this left hand side expression is equivalent to this right hand side expression. But in this right hand side, we know what is the value of V. So we can write lambda. Okay. This is the basically output here, and we know this vector V, therefore we can express 6 is a multiple of 4. Are you getting my point what I did?
Yes, sir.
Intuitively, I got to know that if I am considering one is a vector, we know with what value I will multiply this vector, we will get the result 6, 24. This is the 6. So our eigenvalue is 6.
Six.
This is eigenvalue we attained, we concluded once any matrix A and eigenvector is given. If you don't know any eigenvector, only one matrix A is given, -6, 3, 4, 5. You need to determine eigenvalue as well as eigenvector. So you need to know what the eigenvalue, also you need to know what the eigenvector. For this, you need to develop some kind of characteristic equations. Please don't forget these characteristic equations. Okay, this is the first expression I portrayed in front of you. If you want to subtract this right hand expression from this left hand expression, you should ensure the size of this is equivalent to the size of the matrix A. For this, what you need to do, you need to consider some kind of identity matrix such that the size of identity matrix should be equivalent to the size of matrix A. Therefore, you can write do you have any objection? Identity matrix is equivalent to what? 1. But just you need to confirm the size of this one. So, you consider this simple steps. You can write this. Here, this eigenvector is common in both the terms. So, you can write by dividing eigenvector both the sides, you will get this expression. Until here, is it clear?
Yes.
See, this is the expression I made. I induced identity matrix in order to maintain the size of a matrix A for subtraction or addition purpose. So here subtraction by bringing this on the left hand side. So by considering this term as a common multiple in both the terms, so by dividing both sides B here, this whole becomes 0 and we will get rid of this eigenvector, remaining this we will get. And this is known as eigen characteristic equations. Now we know what is the value of this matrix A, and we also know that this identity matrix by substituting the value here, -6, 3, 4, 5. This is just some kind of modulus, okay? So keeping its characteristic. Once I am talking about the characteristic, to preserve the data. That's why these are the mod values. Mod values. As I am talking, you people are genius, so you are having this kind of characteristic, geniusness. So yes, you are owning it. So this is preserving it. So this is the scalar value, eigenvalue. We know the size of this identity matrix equivalent to this A. So 2 by 2, this one. So equivalent to 0. And further, once we multiply this lambda with 1, 1, and subtracting from there, we will get this kind of expression. Okay. -6 minus lambda, 4, 5 minus lambda, 3. By cross multiplication, we will get. You did not get it? No? Here, this multiply with this lambda, lambda. This is negative sign. This will add into this first element.
Yes, sir.
Then 0 will add in 3, of course 3. This 0 add in 4, 4. Then this subtracted lambda from 5. This is 5 minus lambda.
Yes, sir.
Minus 6 minus lambda, 3, 4 will not be affected due to 0. So here minus lambda at this position, diagonal position. Now by cross multiplication, in order to get a determinant, so you will have this expression, or you can say you want to determine the value of, so negative sign. So what is it? 12.
mod भी होगा ना सर साहब?
Sorry?
mod भी होगा ना साहब?
It is the outside, my son. Is it okay?
Yes, sir.
We consider it or not, it's not affect at this place. So by further here we multiplying it, what will be the value here? So lambda scale, somehow you will get
minus 42
plus lambda and 6 5 is 30 and will be added. So what the minus 40 to equal to 0. So by further factorization you can write lambda plus 7 minus 6 lambda plus 7. You will get two possible eigenvalues. One is the lambda minus 6, sorry, this one minus 6 lambda plus 7. So you can say here one is minus 6
plus
plus 6 and another one is the these are the two possible eigenvalues. Now we are considering this first one. I need your kind attention.
Yes, sir.
Please. Now what we get? We get this eigenvalue. According to the expression, we know what is the matrix. Minus 6, 3, 4, 5. Okay, this is the suppose some eigenvector, and this eigenvector alpha beta unknown to us. Two element of the vectors, and lambda is what? 6. And again alpha beta. To write this expression in form of an equation, you multiply 6 alpha 6 beta, so we will get two equations. You will multiply first row with this minus 6 alpha plus 3 beta equivalent to 6 alpha. Minus 6 alpha plus 3 beta equivalent to 6 alpha. This is your first equations. The second one, 4 alpha plus 5 beta equivalent to 6 beta. 6 beta. I am begging your kind attention. I know you are too busy in many other tasks, but you know, this is just gupshup lectures. From equation 1, from equation 1, you can write 3 beta equivalent to 12 alpha, or simply you can say beta equivalent to 4 alpha. Here, if you consider, please, I need your kind attention, I know you are busy. If alpha equivalent to 1, then what will be the value of beta? 4. Brilliant. You substitute the value of alpha here, you will get beta equal to 4. So, your vector, eigenvector, alpha, beta, equivalent to what? 1, 4.
Yes, sir.
So, your eigenvalue is what? Your eigenvalue is 6. Your eigenvector 1, 4. This all you deduced from only this given. Okay, this is. Okay,
previous result है।
this one. No, not previous.
वो जो पीछे हमने वैल्यू निकाली 6 आई
This is a cross confirmed. We confirmed it. But in exam, I may give you one matrix. I may request please determine its eigenvalue, its eigenvector, with the help of characteristic equation, you need to know about it.
Yes.
Is it clear?
Yes.
The next slide, करें?
Yes, please.
अभी.
Yes, please. Yes, please.
Last वाला जो slide उसका.
Last.
ठीक है सर.
Okay, thank you so much. Okay, now please, until we did not study, just yes, please.
अल्फा सर किस तरह है?
Sorry,
वो बैक साइड
Alpha
वन किस तरह है?
alpha.
वन किस तरह है? वेक्टर
Yes, you can consider alpha equivalent to 0. Then this does not make any sense. But if you are considering alpha equivalent to 2, suppose alpha equivalent to 2, then what should be your beta? 8. 8, you are writing v equivalent to 2, 8. Then is there anything common in it? 2. Then you can write 2, 1, 4. Basically vector is this. On intuitiveness, okay? You need to utilize your wonderful brain. Are you getting my point? Okay, the important thing is this. I can understand you are tired. So important thing, the concept of eigen values. If your eigenvalue, your vector is something which will not change if it is eigenvector. For example, you people are genius. This is your eigen, your characteristic. But if you will work hard, you will get 4 out of 4 GPA. If you will not work hard, you will get 0. This 0 or 4 eigenvalue. But your characteristic is this, you are genius. Another thing is hadarami. That is, are you getting my point?
Yes, yes, sir.
But technically you are genius. And genius is what? Characteristic. So characteristic is what? It is kind of eigenvector. You will work hard, eigenvalue. Not work hard, eigenvalue. So vector is some kind of a constant, okay, it's a fixed thing. If lambda eigenvalue is 1, it is vector, it will not change the vector. See, here we know AV equal to lambda V. If we consider 1 multiply with vector, it's again V.
Yes.
It will not change. However, if we are considering eigenvalue 2, it means it will twice the magnitude of vector. It's a scalar thing. 1 kilogram sugar, 2 kilogram sugar. Okay? If you are multiplying 100 kilometer with 2, then it becomes 200 kilometer in some particular direction. So, if you are considering eigenvalue negative, then it will reverse the direction. Eigenvalue, what will do? It will transform the data. Eigenvector is characteristic. Eigenvalue is using for transformation. And this word eigen, basically this word is representing, this is a German word. Eigen word. That is eigenvector. But what is the eigen itself? Eigen is representing some kind of a characteristic. In German language, if you are talking about some personality or some characteristic, you can say, das ist ein Eigen. Das ist ein Eigen means, do you have some it's talking about your characteristic. Are you a man of words? Are you getting my point?
Yes.
What I want to say? The eigen characteristic.
Features.
Do you have some features?
Yes, sir.
This is the thing. That is ein Eigen. This is the German. Okay, in German basically they are look like Arabic, but the eigen what means that characteristic vector.
Yes, sir.
So if you are talking about more, for example, there are two vectors. One is the x1, another is the x2. If you notice, x1 is kind of a horizontal. But if I make this shape, and did you notice now x1 is changing its position? Now it is not more horizontal. But your other vector x2 is in the same inclined position. Are you getting my point? See here, can you notice please? x2 is in inclined position, x1 is horizontal. But if some kind of deformation, some kind of elasticity is happening, x1 is changing, x2 is not changing.
Same eigenvalue.
X2 is then among these two vectors, which one is eigen? x2.
Yes, sir.
Among these two vectors, x2 is eigen, x1 is not an eigenvector.
Yes.
Okay, again the same expression here. You can see this is matrix, and now you concluded matrix is not a big thing. Matrix is kind of a data. You need to extract feature. Basically the important thing is what eigenvector, kind of a characteristic vector. And you know, if you in other words, this matrix is just equivalent to some kind of eigenvalue, some single scalar value. And if I portray further, eigenvector does not change. For example, your horizontal axis here, white is the eigenvector. You are transforming this image, the upper body is some kind of transforming, but your horizontal axis, this is not changing. Characteristic. Moreover, this one is the purple is eigenvector, blue is changing, but on what? You can observe, for example, here. Please, I am begging your kind attention. If there is no ground, then if you are rotating this in the air, it will affect? No. Okay? But if you are considering this, then it will touch somewhere to my palm. Are you getting my point? But if there is no palm or no ground, then it will not, it's again in the air. Are you getting my point? So, if there is some ground, one axis is fixed, another is changing, so fixed one is known as eigenvector, who is keeping its characteristic. The other vector is not an eigenvector.
Constant vector.
Yes, you can say. Okay, here physical meaning a lot. For example, we are stretching our skin, it is having some kind of elasticity. Surgeon is doing, or we are getting some kind of injury or whatsoever, then it is healed up again. Due to what reason? Due to eigenvector. Okay, body is similarly springs. We are stretching it. After releasing, spring is adopting its position again. Then what is this? Basically due to its eigenvector nature. But how much you are stretching or how much it will shrink, it is what? Eigenvalue.
Yes, sir.
All the engineering, all the linear algebra, all the transformation in this here, from your childhood, you are growing up. So everything basically representing some kind of depending upon eigenvector and eigenvalue. If you consider further, this is not only limited to the linear algebra, calculus, whatever you are considering some kind of a population studies, aeronautics, digital signal processing, facial recognition, Google's original page rank algorithm. If some of you are making some kind of a page, YouTube channel, if it is having very good, first thing, YouTube channel is showing some kind of a characteristic that it is existing. If it is too good with contents, then of course it will be very much popular.
Yes.
Popularity is gained depending upon its content nature, or you can say the strength or whatsoever value, characteristic value. But characteristics is this, there should be a YouTube channel.
Yes.
Okay, so similarly, group page ranking is good, ranking is bad. This is kind of a value. Positive eigenvalue can be 1, eigenvalue can be negative, or there is no change. Okay, for long duration you are, so this is another theory, but all the engineering is there. Here one is, sometimes I really my nervous is getting, okay, breakdown kind of thing, because you people are too genius. To teach you people is kind of, okay, heart attack. However, I am bound to teach you. Suppose this one is a tiger.
Yes, sir.
And if, yeah, it is a tiger. And if we see, do you say it's a cat?
It's a tiger.
No, you will say again it's a tiger.
Yes, sir.
Why? Because eigenvector. If I say 2 eyes, stop, for its hairs, 4 legs, 2 ears, look like cat.
Yes.
The size can be increased or decreased, but you will say it's a tiger.
Yes.
Why? Eigenvector is characteristic.
Yes, sir.
Like you people are genius.
Yes.
If someone is stopping me on a roadside, sir, he is your student, she is your student, she is not student. Oh, come on, they are genius.
Yes, sir.
So this is what, if, okay, Daniel, can you please read it out loud?
When we look at the above picture data and identify it as tiger, what are some of the key information, dimensions, principal components you use to call it out as tiger? Is it not the body, face, legs, etc. information? These principal components, dimensions can be seen as eigenvectors, with each one of them having their own characteristics. For example, body will have elements such as color, build, shape, etc. Face will have elements such as nose, eyes, colors, etc. The overall data image can be seen as transformation matrix. The data transformation matrix, when acted as eigenvector, principal components will result the eigenvectors multiplied by the scale factors, eigenvalues, and accordingly you can identify them as the tigers.
Yes. Of course, even we reduced its size, but due to certain nature of an eigenvector, you will identify it as a tiger, not a cat. Furthermore, Amirullah, please.
The solution to real-world problems often depends upon the processing large volume of the data represented different variables or dimensions. For example, take the problem of predicting the stock prices. There is a machine learning predictive analytic problems. Here the dependent value is stock price, and there are a large number of independent variables on which the stock price depends. Using large number of independent variables, also called features, training one or more machine learning models for predicting the stock price will be computationally intensive. Such models turn out to be more complex models.
Okay, see, our stock market is booming or it's reducing the values depending upon many factors. For example, kind of our behaviors, being an agriculture country, is it raining or not, prices of oils, many factors, okay, many factors are involved. Then these important factors are kind of eigenvectors. So the behaviors, for example, we are struggling hard or not, this is the eigenvalue, and it all depends, predict some kind of a stock market value. Yes, Umar, please.
Feature extraction algorithms such as principal component analysis depend on the concept of eigenvalues and eigenvectors to reduce the dimensionality of the data features or compress the data compression in the form of principal components while retaining most of the original information.
Thank you so much. For example, nowadays digital images are having huge pixels. Okay, so we can reduce this big size of a picture in small numbers. Still we can recognize this is the picture of Umar. Even with simple dot, if some artist can make it, or just edges of the face expression, we can recognize. What is happening? Basically we are reducing the data, but there is one thing existing still as it is. This is eigenvector characteristic.
Yes, sir.
If it is too populated, the eigenvalue will be improved or increased, or you can decrease the eigenvalue. But if there is the eigenvector, then you can increase or decrease the size or reduction in terms of pixels values. Okay, yes, please read out.
I mean, eigenvalues and eigenvectors of a matrix can be useful for solving problems in product fields such as sum of
dimensionality reduction, PCA, facial recognition, designing communication systems, designing bridges, vibration analysis, stability analysis, quantum computing, electrical and mechanical engineering, determining oil reserve by oil companies, constructing design stability of system.
Thank you. Okay, notice please. In suppose I will not explain too many things, but here bridges. Okay. For example, you are talking about some bridges. There are two pillars. You know slab here. Once the heavy traffic is passing over here, so it may possible it's little bend, but if it will maintain its length, eigenvector, length of a vector will be maintained. If it will not be maintained, then bridge will be collapsed. Okay, so somewhere some kind of elasticity is there, but it is retaining its position as it is. So in a similar nature, in oil companies, once they are exploring the oil in particular land, in particular area, with some characteristics, they can state out that there is little bit amount of oil. Amount of oil less or can be too much, that is kind of eigenvalue, but the oil, existing of oil is there is depending upon oil characteristics. Okay, in all the system these are many things. Okay, one more thing here I would like to say, eigenvector values and eigenvectors are only defined for square matrix. If the matrices or data is not a square, if it's kind of a rectangular, then you need to break into the small chunks, small square matrices. Another thing is this, zero vector is kind of a trivial solution. Remember, eigenvalue can be zero, but eigenvector should not be zero. For example, you are genius. Can you get zero score or not? Yes, you can get. Zero is what? Eigenvalue. Though you are genius, you got admission over there, but you are not struggling hard, you are not writing anything, then eigenvalue can be zero.
Yes, sir.
Yeah, interpretation, the linear transformation implied by or cannot change the direction of the eigenvector, but change only their magnitude. Remember, here, the linear transformation implied if you are multiplying some vector, remember, please, I'm begging you, if there, matrices, if you are multiplying the linear transformation, simple, you are talking about in the linearity case, magnitude size can be increased, decreased or reversed, some kind of thing, but it will not change the transformation. If it is some kind of a linear, you cannot say it will become like this or it will become circular. No, it's again the linear. If some vector, okay, let me explain here. Okay, there is a genetics. With the help of eigenvectors, you can determine some person DNA that is belong to the following tribes, to the following members, due to certain characteristics of DNA, genome, genes, and these are the little questions may I ask in the final exam. Yes. What is mean by eigenvalue? Eigenvalue are basically characteristics or latent roots associated with the system of linear equations. We are talking about the linear data. That is the eigenvalue. Yes, can eigenvalue be zero? Yes. You should not forget it, because if you will not study hard, then you will get zero. Okay, though I should not promise this. How many eigenvalues does a 2 by 2 matrix can have? If matrix is a 2 by 2, then there are 2 eigenvalues. Okay? You are not feeling well, Sana? Sleepy? Sit in. Good. Sit in. Define the eigenvalues of a matrix A.
Where is your point in that?
So this one?
Yes.
Yeah, a moment ago there was a 2 by 2 matrix. We evaluated how many eigenvalues we got? 2. Okay, factorization because they are quadratic equation.
Yes, sir.
Are you getting my point?
सर उन दोनों में से हम कैसे कहेंगे कि हमारे काम की कौन सी है?
Both are. You need to prove it. You need to check it out. Okay? Both are the possibilities are there. You need to check it out. Usually we consider the positive one. Okay, here, two properties of the eigenvalues. Eigenvector is distinct, eigenvalues are linearly independent. How? For example, Sharyar is sitting here. He is too genius, and I am a dull student. He is genius. Characteristic of his is not matching with me. Everyone is appreciating him, not to me. So, though we here remember, eigenvector with distinct eigenvalues. He is getting 100 out of 100. I am getting 0 out of 100. So eigenvalues are distinct. Then linearly independent. We are not depending actually on one another. Are you getting my point?
Yes, sir.
This is one property. Singular matrices have 0 eigenvalues. Determinant equivalent to 0.
Yes, sir.
I have no idea.
No.
So sorry, I apologized. This one is the eigenvectors with distinct eigenvalues. Distinct means
Different.
different. You and Miramza both are having different nature. Okay? You are struggling hard, he is sleeping all day. Okay? He is not struggling hard. So different. Are you depending upon one another or not?
No.
No? So linearly
सर
independent.
अगर आइगन वेक्टर सेम हो ये तो डिफरेंट वेक्टर है अगर वेक्टर एक ही हो और वैल्यूज डिफरेंट हो
This is the same. The vectors both are genius. One is struggling hard. You all are genius. I told you. Vectors are same. Eigenvectors with distinct eigenvalues mean eigenvectors are same.
ओके
Is it clear?
यस सर
Singular matrices have 0 eigenvalues. The determinant is 0. Singular, so eigenvalues are 0. For example, you cannot get admission here, okay, in this institute. Of course, you will not get degree from here. Here, please, I skipped one. For example, there is some eigenvector x. You are multiplying with matrix A. You can increase its size.
Yes.
I said that you will not make it in a circular form. No transformation. You can increase or decrease or somehow reverse magnitude can be.
No,
Okay. Are you getting my point?
Yes.
यस सर
So, eigenvalues can be of any value 0,
To positive infinity.
yeah, positive infinity. Is it clear?
यस सर
Eigenvalues and eigenvectors are not defined for rectangular
Only
matrices.
matrix.
I already explained.
यस सर
Yes, sir.
In case of rectangular matrices, you can deal with the data, but you need to split it into the square matrices. Square symmetric matrices have real eigenvalues and a complete set of orthonormal eigenvectors. You need to study it. All eigenvalues are positive definite matrix. Do you know about the positive definite matrix? There is one student who did not appear in a quiz. Who is? Will you present the, or you want 0 score in quiz? No force. If you want to keep it eigenvalue 0 of your quiz, then we will not change it. But if you want to present in a better way, then we will change this 0. Will you present? Okay. Clapping for Laiba. Positive definite matrix and positive semi-definite matrix. She will explain. Is it okay?
Yes.
This is data for your practice. This is website set osa.io. You can set OSA eigenvector, eigenvalue. You can check on the Google. You can play with eigenvalues. It will tell you many things. You have some. Now this is my field. You know. Yes. You know. Yes. You know. Okay. See. Yes. No, it's any kind of, okay. I'm from my childhood, I love the mechanics system. In the car, there are springs. Whenever a car is passing, many shafts, many axles, everywhere there are huge number of springs. Okay, one car is passing through some jump. Okay, you are not getting a huge jerk. Your journey is kind of a smooth journey. Due to what? Suspension, and this is eigenvector.
Yes, sir.
Okay, maybe the jump is too high or too less, this is the eigenvalue, but to keep it back, it's to retain its back or original position, or you can, if for example I told you that if eigenvalue equal to 1, no change.
No change, yes.
Your car will running on a motorway, no jump. Okay?